this series, the sum from k equals 1 to infinity, of negative 2 to the k divided by k to the 10. And let's determine whether this series converges or diverges. Now, it turns out there are multiple tests that we could do to determine whether this series diverges or converges. But we note that we have a k in the exponent. Here we have negative 2 raised to the k. So one natural test that we could use is the root test. So let's see how the root test helps us determine whether this series converges or diverges. So we need to look at the limit as k goes to infinity of the kth root of the absolute value of a sub k, right? Where a sub k is just the kth term in the series, so it's just this expression right here. So this becomes the limit as k goes to infinity of the kth root of the absolute value of negative 2 to the k over k to the 10. Right? And let's think about what this absolute value does. The k to the 10 will always be positive because k is positive. And the negative 2 to the k might be positive, it might be negative. But once we take the absolute value, it's always positive. So I can just think of this as the limit as k goes to infinity of the kth root of positive 2 to the k divided by k to the 10. Right? I can just move the absolute value inside the exponent and turn this negative 2 into a positive 2. And let's rewrite this one more time just to make it a little easier. This is the limit as k goes to infinity of 2 to the k over k to the 10 raised to the 1 over k. Right? When I take the kth root, that's the same as taking the 1 over k power of my expression. So now this limit, right, I have 2 to the k times 1 over k, right? K times 1 over k, so it would just be 1. So I'm just left with 2 in my numerator. And then I have k to the 10 times 1 over k, or k to the 10 over k in my denominator. And let me rewrite the denominator one more time. So I get the limit as k goes to infinity of 2 divided by k to the 1 over k raised to the 10. Now, we've shown in another video that the limit as k goes to infinity of k to the 1 over k is equal to 1. I'll put a link in the description for that video. And so this limit becomes just 2 over 1 to the 10, right, which is just 2. Now, the root test tells me to take this limit, right, the kth root of the absolute value of a sub k. And if this limit is greater than 1, which 2 is greater than 1, then the root test says that this series diverges. So thus, the series sum from k equals 1 to infinity of negative 2 to the k over k to the 10 diverges by the root